Hello, have a good night. This is my second homework of algorithm design and analysis. In here topic is asymptotic analysis, and ChatGPT gave me this question. F of n equal 3n over 2 plus 2n plus 1. G of n equals 2n over 3 plus 4n over 2 plus 5. And to comparing them in big theta and big omega operation, we can ignore this part actually, and f of n becoming n over 2 and g of n equals n over 3. As I mentioned in here, the growth rate of g of n is much more than f of n. And to comparing the theta compression, actually big O notation is kind of for the worst cases, and omega notation for the best cases, and theta we actually could say average case, and it will be equal again as big O notation. And to comparing in the as we can mention in here, actually none of them is f of n is og big O of g of n to others, and none of them. And I sent here to my question, and ChatGPT wrote me about I said in none of them, and it said there's a relationship between them, as in here. And when I asked what kind of relationship, it gives me this one, f of n and OFGN. It's comparing them. And for my second question is here, kind of sorting algorithm comparing. The algorithm A is big O of n log n, and algorithm B is O of n over 2. And the questions are, which one is more efficient in small size and large input sizes, and determining of them, and which one you gonna prefer. In here, all against more efficient on small and large sizes. If we can compare it, let's imagine n equal 1, even in here, it will be 1 over 2 equal 1. Yes, that's right. And 1 log n, it's almost the same for being 2. If we give 2, the algorithm B will be equal to 4, and algorithm A will be less than it. It will be equal to algorithm, it will be equal to 2, and if we make it n equal to 3, the B will be need to more time rather than A in all the time. Actually, if we graph to n, the efficiency rate will be more dramatically. And to coming to questions again, if I'm gonna write a sorting algorithm, I prefer always to using algorithm A. As I mentioned, it's more efficient all the time. And actually, these are the same questions I mentioned in here, there too. And I ask my questions, and it gives me the answers on 3. I just write n equal 1 whenever n growth rate of efficient between them will be more dramatically. And it gives me, it's not possible to determine a specific value of n at which these algorithms have approximately the same efficiency. The reason is that n would have to be so large that the log n factor in algorithm A's time complexity will eventually dominate the compression. But in the practice, this will be a very large value of n. The relationship between these two complexities is not straightforward and cannot be determined by simple equation the expression. Actually, I just write in here to make a little bit more clear for my homework. And then I ask for the hard question, and it gives me to comparing two algorithms, x and u. X equal to 2 over n, and u is a factorial algorithm. And in here, to comparing the complexities, x equal big O 2 over n, y equal over 2 over n. U is less efficient because, let's imagine if you n equal 10, let's say it, x will be 1024, and probably I cannot even calculate the value of 10 factorial. Actually, I little bit expand in here. This is 5 factorial equal to 5 factorial equal to 120, and 6 factorial will be equal to 720. The reason of it, algorithm X always double itself, but algorithm U multiply itself by the size of the input. So its growth rate always will be much more. And coming to comparing the complexity of the algorithm X and U in terms of the big omega, in average it will be the same as the big O notation over 2 over n and factorial. Big omega will be the same. Actually, if there is a n equal 4, the factorial algorithm will be much more efficient, but less than 4 actually. If our input is like 1, 2, or 3, the algorithm U will be more efficient. But otherwise, always, algorithm X will be more efficient. As we mentioned in here, and if I have to choose one of them in these algorithms, I prefer to choose an algorithm X. It always will be more efficient. And I forgot to give the answer of it. It gives me the correct answer, and yeah, you provide a qualitative description of the growth rates, which is fine. The cap point here is the algorithm x2 over n always doubles its number of operation as n increases by 1, where algorithm u and factorial multiplies itself number of the operation by the value of n itself. This means algorithm u's growth rate is super exponential, which makes it extremely inefficient for large n. Yeah, actually, I just want to try to saying this one. And I guess that's all for the homework 2. Thanks for the listening. Have a good day.